Chapter 9. Tokens. The word token comes from the Old English token, which means a sign or mark. This is widely used to refer to privately distributed coin-like objects of negligible intrinsic value, such as tokens for travel, laundry tokens, and tokens for arcade gameplay. Nowadays, blockchain-administrated tokens redefine the word to mean blockchain-based abstracts, which can be owned and represent properties, money, or access rights. The association between the term token and negligible meaning has something to do with the restricted use of tokens' physical versions. Physical tokens are often limited to particular companies, organizations, or locations, and are not readily exchangeable and usually have one purpose only. Such limitations are removed with blockchain tokens, or, more precisely, fully redefinable. Most blockchain tokens have several roles globally and are tradable on global liquid markets for one another or for other currencies. With the use and ownership constraints gone, the presumption of insignificant interest is also a thing of the past. We look at various uses for tokens in this chapter and how they are made. We're also debating token attributes such as fungibility and intrinsicity. Finally, by creating our own tokens, we investigate the principles and technologies upon which they are based, and experiment. How tokens are used. Like digital private currencies, the most obvious use of tokens, this is but one potential use though. Tokens can be programmed to serve several different, often overlapping roles. For example, a token may express a voting right, a right of access and ownership of a resource at the same time. Currency. A token may serve as a type of currency, with a value decided by private trade. Resource. A token can represent a resource received or generated in a sharing economy or research sharing environment. For example, a resource storage or CPO token can be shared through a network. Commodity. A token may represent ownership of an intrinsic or extrinsic, tangible or intangible commodity, such as cash, immovable property, a vehicle, oil, electricity, MMOG objects, etc. Access. A token may represent access rights and grant access to digital or physical property, such as a discussion forum, an exclusive website, a hotel room, or a rental car. Equity. A token may represent shareholder equity in a digital company, for example, a DAO, or legal entity, for example, a corporation. Voting. In a digital or legal system, voting a token can reflect voting rights. Collectible. A token may represent a digital collectible, for example, CryptoPunks, or a physical collectible, a painting. Identity. A token may represent a digital identity, for example, an avatar, or legal identity, for example, national identity. Attestation. A token may be a credential or a credential of truth by some authority or a decentralized system of legitimacy, e.g., marriage record, birth certificate, college degree. Utility. A token can be used to access a service or to pay for it. Also, all of these functions are composed of a single token. Often, it is hard to distinguish between them because the physical similarities have been inextricably related. A driver's license is also an identification certificate, in the real world, for example, and the two cannot be distinguished. In the digital domain, previously combined functions may be independently isolated and created, e.g., an anonymous attestation. Tokens and fungibility. Wikipedia says in economics, fungibility is the property of a good or a service whose individual units are basically interchangeable. Tokens are fungible because we can replace any single unit of the token with another, without any difference in its value or purpose. Strictly speaking, if the historical provenance of a token can be traced, then it is not fully fungible. Provenance monitoring capability can lead to blacklisting and whitelisting, reducing or removing fungibility. Non-fungible tokens are tokens each representing a specific tangible or intangible object, and are therefore not interchangeable. For example, a token representing ownership of a particular Van Gogh painting is not equal to another token representing a Picasso, although it may be part of the same art ownership token scheme. Likewise, it is not synonymous with any other CryptoKitty token representing a particular digital collectible, such as a particular CryptoKitty. A distinctive identifier, such as a serial number, is related with each non-fungible token. Note that fungible is often used to mean directly exchangeable for money. For example, a casino token can be cashed in, while laundry tokens are not normally possible. That's not the reason we're using the word here. Counterparty risk. Counterparty risk is the jeopardy that the other party may fail to fulfill its obligations in a transaction. Many forms of transactions are subject to increased counterparty risk due to involvement of more than two parties. For instance, if you hold a deposit certificate for a precious metal and you sell it to someone, there are at least three parties in that transaction: the seller, the buyer, and the precious metal custodian. One owns the physical asset. They are party to that transaction's execution through default and attack counterparty risk to any transaction involving that asset. In general, when an asset is traded indirectly through the exchange of a token of ownership, the custodian of the asset poses potential counterparty risk. Have they got the assets? Will they accept or permit ownership transfer based on a token transfer, such as a certificate, deed, title, or digital token? In the world of asset representing digital tokens, as in the non-digital world, it is important to consider who owns the asset represented by the token and what laws are applicable to that asset. Tokens and intrinsicality. The word intrinsic derives from the Latin word intra, meaning from within. Some tokens represent digital objects intrinsic to the blockchain. These digital properties, much like the tokens themselves, are regulated by consensus laws. It has a significant implication. No external counterparty risk carries tokens that represent intrinsic properties. If you have the keys for a CryptoKitty, risk carries tokens and represents intrinsic properties. If you have the keys for a CryptoKitty, no other party owns the CryptoKitty for you. You directly own it. The blockchain consensus rules apply, and the ownership, i.e. control, of the private keys without any intermediary is equal to ownership of the asset. In comparison, several tokens are used to represent extrinsic objects like real estate, corporate voting rights, trademarks, and bars of gold. Ownership of these objects, which are not within the blockchain, is regulated by statute, tradition, and policy, separate from the rules regulating the token by consensus. In other words, token issuers and proprietors can still depend on non-smart real-world contracts. As a consequence, these extrinsic assets bear additional counterparty risk as they are owned by custodians, registered in external registries, or regulated outside of the blockchain setting by regulations and policies. The ability to turn extrinsic assets into intrinsic assets and thus reduce counterparty risk is one of the most important consensus of blockchain-based tokens. A clear example is the change from equity in an extrinsic company to equity or voting token in a DAO or similar intrinsic organization. Use tokens, utility or equity. Almost all Ethereum projects launch with some form of token today, but do all these projects need tokens really? Are there any drawbacks of using a token, or are we going to see the tokenize all things slogan come to fruit? The use of tokens should, in theory, be seen as the primary method of management or organization. In reality, the introduction of blockchain systems like Ethereum into the current frameworks of society means that their applicability has so far been subject to many limitations. Let's just begin by clarifying a token's position in a new project. Many projects use tokens in one of two ways: either as tokens of value or as equity tokens. Too frequently, these two positions are conflated. Utility tokens are those where access to a device, program, or resource requires the use of the tokens. Types of utility tokens include tokens representing resources like shared storage or access to services like social media networks. Equity tokens are those reflecting equity in managing or owning something, such as a company. Equity tokens may be as confined as non-voting shares for dividend and benefit distribution, or as expansive as voting shares in a decentralized autonomous association, where network control is focused on voting by token holders through some dynamic governance mechanism. It's a duck. Most startups are facing a difficult problem. Tokens are a fantastic funding tool, but in most jurisdictions, selling shares, equity, to the public is a controlled practice. By distinguishing equity tokens as utility tokens, many companies aim to bypass these regulatory restrictions and raise capital from a public offering when posing it as a pre-sale of service access vouchers, or utility tokens, as we call them. It remains to be seen if such thinly veiled equity deals would be able to circumvent the regulators. As the famous saying goes, if it walks like a duck and quacks like a duck, it's a duck. Regulators are unlikely to be fooled by such contortions. Quite the contrary. They are more likely to see these legal sophistry as an attempt to mislead the public. Tokens for utility. Who wants them? The key challenge for entrepreneurs is that utility tokens pose major risks and obstacles to adoption. Perhaps tokenize all things would become fact in the near future, but at present, the group of people who have an awareness and ability to use a token is a subset of the already limited cryptocurrency market. Each invention represents both a risk and a demand filter for a startup. Innovation is taking the least traveled route, away from the conventional course. It is a lonely trip even. When a startup wants to innovate in a new technology field, like sharing storage over P2P networks, that's a lonely enough road. Adding a utility token to the innovation and allowing consumers to accept tokens to access the service increases the risk and heightens barriers to adoption. It's stepping off the already lonely trail of creativity in P2P storage and into the wild. Think of a novelty as a filter. It restricts the acceptance of this product to the subset of the market that can become early adopters. Apply this effect to a second filter product, further restricting the addressable market. You are asking your early adopters to embrace not one, but two comprehensively latest technologies. The latest application or platform or service you have developed, and the token economy. That invention introduces risks for a startup, which increase the startup's chance of failure. If you take your already risky business concept and add a utility token, you add all the risk associated with the underlying network, Ethereum, wider economy, exchanges or liquidity, regularity environment, equity or commodity regulators, and technology, smart contracts, token standards. For a startup, that is a lot of risk. Advocates of tokenize all things would possibly argue that they still inherit consumer interest, early adopters, technology, creativity, and the competitiveness of the entire token economy by adopting tokens. This too is real. The problem is whether the risk and uncertainties outweigh the advantages and excitement. Yet in the crypto world, some of the most creative business concepts actually take place. If regulators are not fast enough to enact laws and embrace emerging business models, entrepreneurs and associated talent may continue to work in more crypto-friendly jurisdictions, that is already taking place. Finally, at the beginning of this chapter, we address the colloquial sense of token as anything of insufficient value when implementing tokens. The underlying explanation for the insignificant value of most tokens is that they can only be used in a rather limited context. One bus service, one laundromat, one arcade, one hotel, or one company store. Restricted liquidity, minimal applicability, and high cost of conversion minimize tokens' value until they are of card value only. But when you add a utility token to your network, but the token can only be used with a limited market on your single platform, you replicate the conditions that make physical tokens worthless. It might potentially be the best way to integrate tokenization into your project. However, if a user needs to convert it into your utility token in order to access your site, use it and then turn the rest back into something more commonly usable, you've created a business script. A digital's token switching costs are orders of magnitude smaller than for a non-market physical token, but they are not zero. Utility tokens that operate through a whole business field would be really interesting and definitely worthwhile. But if you set up your company to have a bootstrap a whole industry standard to be successful, you will already have failed. Note, one of the benefits of deploying services on general-purpose platforms, such as Ethereum, being able to link smart contracts, and hence the usefulness of tokens, through projects. The liquidity and utility potential of tokens. Take the call on the right grounds. Adopt a token, because without a token, the application can't function. Adopt this because the token removes a fundamental obstacle to the market or addresses an access problem. Do not add a utility token, because this is the only way you can easily raise capital, and you need to believe it is not a public securities deal. Tokens on Ethereum. Until Ethereum, there were tokens on Ethereum blockchain tokens. The first blockchain currency, Bitcoin, is in several respects a token in itself. Before Ethereum, several token networks have also been built on Bitcoin and other cryptocurrencies. The implementation of the first token standard on Ethereum, therefore, resulted in an explosion of tokens. As one of the most simple and practical implementations of a generalized programmable blockchain, such as Ethereum, Vitalik Buterin proposed tokens. In reality, it was popular in Ethereum's first year to see Vitalik and others wearing t-shirts emblazoned with the Ethereum logo and a smart preview of the contract on the back. This t-shirt had many variations, but the most popular showed a token design. It's important to have an overview of how tokens operate on Ethereum before we dive into the specifics of creating tokens on Ethereum. Tokens are distinct from Ether, since they are not recognized by the Ethereum protocol. Receiving Ether is the Ethereum platform's inherent behavior, but it is not receiving or even possessing tokens. The Ether balance of Ethereum accounts is managed at protocol level, while the smart contract level manages the token balance of Ethereum accounts. You must create a new smart contract to create a new token at Ethereum. The smart contract, once implemented, manages everything from ownership, transactions, and access rights. You can write your smart contract to execute all the required acts in any way you want, but following an established model is probably wisest. Next, we should look at those criteria. At the completion of this chapter, we'll discuss the pros and cons of the following principles. The ERC20 token standard. Fabian Vogelsteller implemented the first standard as an Ethereum request for comments, ERC, in November 2015. GitHub issue number 20 was immediately allocated, giving rise to the name ERC20 token. Currently, the vast majority of tokens are based on the ERC20 standard. Finally, the ERC20 proposal for comments became Ethereum's Improvement Proposal 20, EIP to 20, but the original name ERC20 also still applies to this. ERC20 is a standard for fungible tokens, which means that different units of an ERC20 token are interchangeable and do not have any special properties. The ERC-20 specification specifies a generic token implementing contract interface, such that any compatible token can be accessed and used equally. The interface comprises of an amount of functions that must be included in any standard implementation, as well as some optional features and attributes that developers can add. ERC-20 Necessary Functions and Events. At least the following functions and events must be given by an ERC-20 compliant token contract. Total supply returns the total units of this token which currently exist. Tokens with ERC-20 may have a fixed supply or a variable. Balance of returns the token balance for that address given a number. Transfer providing an address and number transfers the number of tokens from the balance of the address that performed the transfer to that address. Transfer form provided a sender, receiver, and number, tokens are transferred from one account to another, used along with approval. Approve provided the address and amount of the recipient authorizes the address to perform multiple transfers up to that amount from the account that provided the approval. Allowance returns the remaining amount followed by the owner for withdrawal by the spender. Transfer event caused after a positive transfer, called to transfer or transfer from, even for transfers with zero value. Approval event signed in for approval after a successful call. ERC-20 Optional Functions. The following optional functions are also specified by the standard in addition to the necessary functions mentioned in the previous section. Name returns the token's human readable name, e.g., US dollars. Symbol returns a token with a human readable symbol, e.g., USD. Decimals returns the number of decimal places used to divide the sum of token. For example, if the decimals are 2, then the sum of the token is divided by 100 in order to get its user representation. Issues with ERC-20 tokens. The adoption of the regular ERC-20 token has been completely explosive. Thousands of tokens were introduced, both for playing with new capabilities and for raising funds in various crowdfunded auctions and ICOs. However, as we saw with the problem of passing tokens to contract addresses, there are some possible pitfalls here. Some of the less apparent problems with ERC-20 tokens is that they reveal subtle variations between the tokens and the Ether themselves, where Ether is exchanged by a transaction with the address of the recipient as its destination. Token transfers take place within the same token contract state and have the token contract as their destination, not the address of the receiver. The contract token monitors balances and issues incidents. No money is essentially sent to the token receiver in a token transfer. Alternatively, the address of the recipient inside the token contract itself is attached to a diagram. A transaction that sends Ether to an address modifies the address status. A transaction that moves a token to an address only changes the token contract status, not the receiver address status. Only a wallet with support for ERC-20 tokens will not become aware of a token balance unless the consumer specifically adds to monitor a particular token contract. Many wallets track the most common token contracts to identify balances kept by the addresses they manage. However, this is restricted to a small fraction of current ERC-20 agreements. In fact, in all possible ERC-20 token contracts, it is unlikely that a user will want to track all the balances. Most ERC-20 tokens look more like spam email than functional tokens. To attract users, they build balances automatically for accounts that have Ether operation. If you have an Ethereum address with a long history of operation, in particular, if it was generated in the pre-sale, you will find it full of junk tokens that came from nowhere. The address isn't really full of tokens, of course. It is the token contracts that have your address in them. You can see these balances if the block explorer or wallet you use to display your address is monitoring certain token contracts. Tokens do not behave the same way Ether does. Ether is sent with the send feature and accepted in a contract or in an externally owned address via any payable feature. Tokens are sent using transfer or approval and transfer from functions that exist only in the ERC20 contract and do not cause, at least in ERC20, any payable functions in a contract with the receiver. Tokens are supposed to work just like an Ether-like cryptocurrency, but they come with some variations that dispute the illusion. Find yet another issue. You need Ether to pay for gas to send Ether or use any Ethereum contract. You need Ether too to send tokens. You can't pay a token for the gas of a transaction, and the token contract cannot pay you for the gas. This may change in the near future, at some point, but this may meanwhile trigger some very weird user experiences. Let's assume, for example, that you are using an exchange or shapeshift to convert some Bitcoin to a token. You receive the token in a wallet that records the contract for that token and shows your balance. This looks like exactly the same as any of the other cryptocurrencies in your pocket. Nonetheless, try sending the token and your wallet will inform you that you need Ether to do that. You may be confused. You didn't need an Ether to obtain the token after all. You still don't have any Ether. You may not have known that the token on Ethereum was an ERC20 token. Perhaps you thought it was a cryptocurrency with its own blockchain. The illusion just collapsed. Many of those problems are unique to tokens from the ERC20. Others are more general issues within Ethereum which relate to abstraction and interface boundaries. Some can be solved by modifying the token interface, while others can require improvements to Ethereum's fundamental structures, such as distinguishing between EAOs and contracts, and transactions and messages. Some may not be necessarily solvable, and may involve user interface design to mask the complexities and keep the user experience consistent, irrespective of the distinctions underlying it. We will look at different ideas in the next sections that aim to fix some of those issues. ERC 223, a proposed token contract interface standard. The ERC 223 specification aims to overcome the issue of the inadvertent transfer of tokens to a contract, which may or may not accept tokens by detecting whether or not the destination address is contract. ERC 223 allows contracts designed to accept tokens to have a token fallback feature implemented. Unless the transfer destination is a contract and there is no support for tokens in the contract, i.e., does not enforce token fallback, the transfer fails. Which are conditions for token? Which is their intended purpose? Token specifications are the minimum implementing requirements. What that means is that you need to at least follow the functions and actions defined by the ERC20 standard in order to be compatible with, say, ERC20. When adding functions which are not part of the standard, you are also free to add to the functionality. Such specifications have the primary function of promoting interoperability between contracts. And all wallets, exchanges, user interfaces, and other components of infrastructure can communicate with any contract that follows the specification in a predictable manner. In other words, if you deploy a contract that meets the ERC20 norm, all current wallet users will trade your tokens seamlessly without any update or effort on your part. The criteria are meant to be descriptive, not prospective. How you want to perform these functions is up to you. The contract's internal operation is not applicable to the norm. They have certain practical criteria that control the actions in particular situations, but do not prescribe an implementation. An example of this is a transfer function behavior if the value is set to 0. Will you have to use these standards? Every developer faces a dilemma given all these requirements: using established standards or innovate outside the constraints they impose. It's not easy to solve this problem. Standards inevitably limit your creative potential by establishing a limited rut you have to meet. At the other hand, the basic principles originated from hundreds of application experience and mostly work well with the vast majority of use cases. There is an even bigger problem as part of this consideration: the importance of interoperability and large acceptance. When you want to use an existing model, you'll receive the advantage of all the programs that are built to operate with it. When you want to deviate from the standard, the expense of constructing the entire support system on your own or persuading others to support your introduction as a new standard must be weighed. The tendencies to forge your own course and disregard accepted norms is known as the phenomenon of not created here. The tendency to forge your own course and disregard accepted norms is known as the phenomenon of not created here and is antithetical to the philosophy of open source. On the other hand, often to change and creatively rely on a departure from tradition. It's a tough decision, so carefully consider it. Safety by maturity. There is the parallel option of implementation outside standard option. You will then determine how to incorporate a compatible design when you determine to use a specification such as ERC20. There are a variety of current template implementations which are commonly used in the ecosystem of Ethereum, or you can write your own from scratch. Again, the option represents a dilemma that can have serious consequences for security. Existing implementations are battle-tested. While it is difficult to prove they are reliable, many of them underpin the tokens worth millions of dollars. They were attacked repeatedly and violently. So far, there has been no major flaws found. It's not easy to write your own. There are several subtle ways to weaken a contract. Using a well-tested, commonly used implementation is a lot better. We use the Open Zeppelin implementation of the ERC20 standard in our examples, as this implementation is from ground up based on security. Whether you are using an existing implementation, you can extend it too. But be vigilant of this urge once again. Complexity is the security enemy. Every single line of code that you add extends your contract's attack surface and may reflect a weakness that lies in wait. You cannot find any problem until you put a great deal of interest on top of the contract and someone breaks it. Note, standards and implementing choices are essential components of safe, smart contract design overall, but they are not the only considerations. Token interface specification extensions. The token specifications discussed in this chapter include a basic interface with restricted functionality. Several companies have built comprehensive implementations to support functionality they need for their applications. Many of these features include owner control, the ability to send unique addresses or collection of addresses, i.e. multi-signature schemes, special functionality such as blacklisting, whitelisting, minting, recovery, etc. Burning, the ability to intentionally burn tokens by moving them to an unspendable address or erasing a balance and decreasing supply. Minting, the capacity of the token maker to add the total token supply at a constant pace or by fiat. Crowdfunding, the ability to sell tokens for sale, e.g. through an auction, market sale, reverse auction, etc. Caps, the ability to set predefined and unchangeable limits on an overall supply, the opposite of minting. Recovery backdoors, functions for recovering money, reversing transactions, or dismantling the token that can be triggered by a given address or address collection. Whitelisting, the right to limit behavior to unique addresses, such as token transfers, most widely used to sell tokens to accredited investors after being vetted by different jurisdiction laws. Typically, there is a whitelist upgrade process. Blacklisting, by disallowing unique addresses, the right to limit token transfers, there's usually a blacklist update feature. Of several of these features, reference implementations exist, e.g., in the Open Zeppelin library, Most of these are case-specific use and implemented only in a few tokens. As of now, there are no generally accepted guidelines about the interfaces to such functions. The decision to expand a token standard with additional features, as discussed earlier, reflects a trade-off between innovation, risk, and interoperability and security. Tokens and IOCs. Tokens have been an explosive development of the Ethereum ecosystem. They're likely to become a very important part of all smart contract systems, such as Ethereum. Nonetheless, the value of these criteria and their potential effect should not be confused with approval of existing token offerings. As with every early-stage technology, almost all of the first wave of products and businesses will fail, and some will fail spectacularly. Many of the tokens on sale in Ethereum today are scams, pyramid schemes, and money grabs that are barely discussed. The challenge is to distinguish the long-term vision and effect of this technology, which is likely to be immense, from the short-term bubble of fraud-ridden token ICOs. Token specifications and the ecosystem will survive the current token mania and will definitely change the world afterwards. Conclusions. In Ethereum, tokens are a very strong idea and can form the basis for many critical decentralized applications.